In this video, we're going to talk about heat pump compressors. When you think about it, a heat pump compressor has to operate in some pretty harsh conditions. They operate in temperatures upwards of 120 degrees in hot climates and down to the minus temperatures in cold climates. So the compressor for a heat pump has to be a pretty robust machine. The most common compressors that are used in small residential equipment are rotary compressors, the Copeland Scroll compressor, reciprocating compressors, and screw compressors. Reciprocating technology has been around for quite some time. This is the compressor that operates much like an automotive engine with a piston and a crankshaft and valves that open and close to the discharge and suction side of the system. Scroll technology has been around for quite some time now and has become a standard in most of our heat pumps and air conditioners, and most technicians are aware of the scroll technology and how it operates. I'm sure all of you have seen how the orbiting scroll goes around inside the fixed scroll and compresses the discharge gas towards the center and discharges it out through the discharge line. The scroll cycle starts with the suction, where the suction inlet comes into the scroll, and then the compression, where the orbiter compresses the gas towards the center, and then it's discharged out through the discharge line. Rotary technology was primarily seen in the ductless equipment and now is coming into more and more of the standard residential type equipment. Breakdown of the internal of a rotary compressor. A rotary compressor usually has an accumulator on the side of it, and the suction gas comes in and hits a screen on the inlet of the accumulator that breaks up any liquid droplets that may have made it back through the suction line before it enters the compressor, and then it is compressed in the rotary cycle and then discharged out through the discharge line. This is the internal workings of a rotary compressor. It has a circle that does the compressing, pulling the suction gas in through the suction port, and then compressing it as the circle goes around a concentric cam, and then discharging it out the discharge line through the discharge valve. So internal on the rotary compressor, you have the suction side that is separated from the high side by the sliding vane. And the suction gas is pulled into the suction port and is then starting to compress as the cam of the rolling piston turns towards the discharge side. And then here is the discharge cycle where the rolling piston is starting to compress the high pressure vapor, and then it will be discharged through the discharge port. Screw technology is usually seen on larger equipment and on most chillers. The screw compressor usually has two rotors, a male rotor and a female rotor that fit in together, and as they turn, they compress the gas from one end to the other. The suction side of the rotors pulls the suction gas into the rotors and compresses it towards the discharge side. Just about all your compressors, the Copeland Scroll, the rotary compressor, and the screw compressor are being converted to inverter technology now, where the compressors start off slow and ramp up and down depending on conditions. Inverter technology is being found not only in the ductless product, but also in most of your residential heat pumps and air conditioners. With inverter technology and electronic expansion valves, the outdoor heat pump is now able to float with the load. Before, with a fixed orifice, the heat pump was not very efficient down to lower temperatures. But now with inverter technology and electronic expansion valves, we can operate heat pumps down into the minus degrees and still get decent heat out of the heat pump. So now, for example, your Copeland Scroll is a DC variable speed motor and will vary from 0 up to 7,000 RPMs depending on the cooling or the heating load. This makes the heat pump extremely efficient in hot temperatures as well as very cold temperatures.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.